So today we're going to write a proof for the area formula of a parallelogram. And this is the shape that we're given. So before we do the proof, let's label some points. This will be L, this is M, N, O, P, and Q. So now the points are labeled. And this is also, so this is a height here, which is labeled H, and this here is the base of this rectangle. So we have the height and the base, and then we have this rectangle is made up of a triangle, a parallelogram, and another triangle. So let's get started on the proof. So first we're given rectangle LNOQ, which is made up of parallelogram MNQP, which is made up of triangle LMQ and triangle NPO. This is all given. So next, let's try to find congruent triangles. So we know that angle L and angle O are 90 degrees, so they're congruent. That's given. And we know by the definition of a rectangle that LQ is congruent to NO. So LQ is equal to NO. That's by the definition of rectangle. And we know that MQ is congruent to NP by definition of parallelogram. So since we know that LMQ, so we know that this is a right triangle because this has a right angle. We also know the hypotenuses are congruent and a leg is congruent, so we can use hypotenuse leg. So triangle LMQ is congruent to triangle NOP. This is by hypotenuse leg. So we know angle L equals angle O, which equals to 90. We know LQ equals NO and MQ equals NP. So these are this right here, MQ, this is the hypotenuse. And this one's the leg. So we know that these are congruent. Thus we can, okay, so now let's see the area. Let's label these areas. The area of this triangle is going to be area S. The area of this parallelogram is going to be area P. And the area of this triangle is going to be area T. So S, P, and T. So let's write that down. Now, let's say S is the area of triangle LMQ. P is the area of parallelogram MNQP, and T is the area of triangle OPN. Okay, so since we know that these two triangles are congruent, we can also say they have the same area. So S equals T. Because congruent shapes have equal area. And we've proved that they're already congruent. Now, overall, let's try to find the parallelogram. So we know that the area of the rectangle is made up of area S, area P, and area T. So the area of rectangle is equal to S plus P plus T. And that is just decomposition. Okay. So we know, which number are we on? We know that the area of the rectangle is equal to the base times the height, so h times b plus a. And that the area of triangle, or area of S, so S is equal to H. And since these are congruent, this is also A, so it's just 1/2 H times A. So we can write in a little A here, because that's the same, because they're congruent. So S equals 1/2 H times A. And we don't need to find the area of T because we know that S and T are just congruent. So T would just be 1/2 H times A as well. So this is because the area of rectangle is equal to base times height. And this is because area of a triangle is equal to 1/2 base times height. So let's look back at this formula we had. Area of rectangle is S plus P plus T. So we know that just the area of the rectangle is 2S plus P. That's just substitution. And then because we know that S plus P plus T, and we know that S equals T, so you can just say 2S plus P. So since we want to find the area of the parallelogram P, let's just simplify. So P equals the area of rectangle minus 2S. This is just simplifying. And now let's just substitute. So we know that P equals, in the area of the rectangle, is H times B plus A. And then the S is equal to 1/2 H times A. But there's two of them, so we have to have two. And that's just substitution. And now let's just simplify. So we have P equals H times B plus H times A minus, and then let's multiply this out. So 2 times 1/2 is just 1, so minus H times A. This is simplify. And then 14P equals, so we have H times B plus H minus A minus H times A. So H times B. And there we go. So therefore, and this is simplifying, therefore the area of the parallelogram is equal to the base, so this is the base for this case, the B, times the height.